The most important discovery ever made on Mars was not planned. It was not on any mission target list. No scientist had flagged it. No orbital photograph had suggested it. No geological model had predicted it would be there. It was found by a machine that was stuck, that could not move, that had, by every measure anyone was using at the time, failed. And what it found, sitting 2 inches below the surface of Mars, in a patch of ground that no one had any reason to investigate, is still being argued about today. Because if what that discovery implies is correct, then Mars was not just a wet planet billions of years ago. It was something more than that. And the only reason we know is because a wheel broke through a crust that looked exactly like every other crust. The machine had been on Mars for 3 years when it happened. 3 years past the point when it was supposed to be dead. Every single day of those 3 years was a day the original mission plan had not accounted for. Every discovery made in year 2, every photograph taken in year 3, every rock analyzed in the months before the wheel broke through, none of it was supposed to happen. The mission had ended, on paper, before any of it occurred. The rover was operating entirely outside the boundaries of its own design. The original mission plan gave it 90 days, 90 Martian days, slightly longer than Earth days, to drive through one specific region, photograph one specific set of targets, analyze one specific set of rocks, and transmit the data home, before the solar panels lost the fight against the accumulating Martian dust. Then silence. That was the plan. The machine was still running in 2007, not because anything dramatic happened, not because of some engineering triumph or last-minute rescue. It was still running because Mars, unexpectedly, helped. Dust devils, small whirlwinds that crossed the Martian surface, passed over the rover periodically and cleaned the solar panels. Nobody had planned for this. Nobody had modeled it. The dust devils of Mars, moving on their own schedules, indifferent to mission plans, kept sweeping the panels cleaned and giving the machine more power than the 90-day calculation had accounted for. The rover was alive on borrowed time. Every day past 90 was a day that should not have existed. And on one of those borrowed days, in 2007, a wheel broke through. 3 years of Martian terrain had not prepared the machine for this particular patch. 3 years of craters and plains and slopes and rock formations that the cameras had photographed and the spectrometers had analyzed, and the wheels had crossed without incident. 3 years of Mars behaving in ways that, while not always exactly as predicted, were at least within the range of what the engineers had modeled. The ground looked like every other piece of ground the machine had crossed for 3 years. That is the thing about Mars that no orbital photograph prepares you for. From above, the surface has a logic to it. Craters, plains, dunes, features that follow patterns that a trained eye can read. On the ground, the logic disappears. What looks stable is sometimes a thin crust over loose material. Descriptions. What looks like terrain that has been traversed 1,000 times is sometimes a trap that has been waiting years for exactly the right weight to come along. The wheel hit the soft patch and broke through. The machine sank, slowly at first. A tilt in the chassis data, a change in wheel resistance, numbers that the team on Earth noticed before the machine itself could react. They sent commands to stop. The machine stopped. They assessed the situation. The rover was stuck. What followed was months of careful, systematic attempts to free it. Reverse thrust, lateral movement, different combinations of wheel speed and direction. The team on Earth sent command after command, waited 14 minutes for the signal to arrive on Mars, waited 14 more minutes for the response to come back, and analyzed what the telemetry showed. The machine moved centimeters, then millimeters, then nothing. And during all of this, during the months of trying and the accumulation of evidence that the machine was not coming out, the instruments kept running. Because the instruments had no reason to stop, the wheels had broken through something. Whatever was underneath, the soft material that the crust had been covering, was now exposed, visible to the cameras, reachable by the spectrometers, and it was the wrong color. Not wrong like a malfunction, wrong like something unexpected, bright, almost white against the dull reddish brown of the Martian surface. Material that had never been exposed to the Martian atmosphere before that wheel came through. The scientists on the mission team saw the images and recognized it immediately. Silica, not common Martian silica. Not the kind that forms slowly through ordinary surface chemistry over billions of years of wind and temperature change. Specifically, a form of silica that on Earth forms in one of two environments: hot springs or steam vents, places where water and heat meet, places where the chemistry is active, where minerals precipitate out of solution, where the conditions are, in a specific and meaningful sense, alive. Not alive with biology, alive with process, with the kind of active chemistry that, on Earth, has been found to preserve evidence of microbial life more reliably than almost any other geological medium. Paleontologists have found billion-year-old microbial fossils in silica deposits on Earth. The silica acts as a time capsule. Whatever was in the environment when the silica formed, organic molecules, chemical signatures, in some cases the physical remains of microbes, gets locked in and preserved. The silica on Mars is billions of years old. The machine that found it was stuck in it. No committee would have chosen this site. That is the thing that sits underneath all of it. The landing site selection process for a Mars mission takes years. Scientists propose candidates, engineers evaluate terrain safety, program managers weigh risk against scientific return. The sites that survive this process are the ones that offer the best combination of scientific interest and mechanical accessibility. The patch of ground where the silica was found was not scientifically interesting from orbit. It looked like everything around it. It offered no particular reason to investigate it. Had the machine been mobile, driving on its planned route, following its planned sequence of targets, it would have passed over this exact spot without stopping. The crust would have held. The silica would still be there, undisturbed, 2 inches below the surface. The question it implies about what kind of Mars created it, about whether the conditions that produced it were warm enough and wet enough and stable enough and long-lasting enough to have hosted something more than chemistry, would not have been asked. Not in 2007, maybe not ever, if no future mission happened to stop at precisely this location. The discovery exists because of the failure, not despite it, because of it. This is not a lesson, not a metaphor, not an inspirational framing of a difficult situation. It is just what happened. The failure and the discovery were the same event. The wheel broke through. The failure occurred. The discovery occurred. In the same moment, in the same patch of ground. You cannot have one without the other. The question is what you do with that. The machine went silent eventually. a Martian winter came. The angle it was stuck at meant the solar panels could not follow the sun the way a mobile rover would. Power dropped. The team sent commands for it to enter a low-power hibernation mode and wait for spring. A reasonable strategy. One that had worked before. Spring came. The sun returned to that region of Mars. The dust devils crossed. The panels should have received enough light to trigger at least a minimal response. Enough to send a signal. Enough to say something. No signal. The team tried for over a year. Hundreds of commands sent to a machine that did not respond. On a specific date, the mission was officially declared over. The rover is still there, right now, in the soft patch of soil where the wheel broke through to in 2007. The machine sits. Martian dust on the panels. Temperature swings that no electronics can indefinitely survive. The instruments that found the silica still physically attached, still pointed at the ground, doing nothing, because there is nothing left to power them. But the data they collected is here, and the silica is still there too, 2 inches below the surface. Still locked in whatever it was locking in when the machine found it, unvisited since 2007. Not on any current mission plan. Not on any near-future mission plan. The most significant chemical discovery of the mission. The one that generated the most scientific argument. The one that most directly implied something remarkable about what Mars once was. Has had no follow-up visitor in nearly 2 decades. The Silica site was visited exactly once. By the machine that discovered it, in the months between. When the wheel broke through, and when the machine finally went silent, the instruments collected everything they could reach from a fixed position. The cameras photographed, the spectrometers analyzed. The data was transmitted home, processed, published, argued over, and then the machine went silent and the argument continued without it. And the site itself has had no visitor since. No sample collection. No core drilling. No follow-up instrument designed specifically to answer the question the first instrument accidentally asked. Nearly 20 years. Scientists are still arguing about what the silica means. One side says the hot spring explanation is correct. That the silica formed in a hydrothermal environment where water and heat produced exactly the kind of chemistry that, on Earth, is associated with early microbial life. That the conditions were there. That Mars, at some point, had everything it needed. The other side is more cautious. Silica can also form through a different process. Steam from volcanic activity interacting with the surface, without the sustained liquid water environment that life would require. Less dramatic, less significant. The same mineral, a different origin, a different implication. The argument matters because of what it implies. If the hot spring explanation is correct, if this silica formed in warm, liquid water, in a sustained hydrothermal environment, then Mars did not just have water. It had active chemistry. It had the kind of energy-rich, mineral-rich, temperature-stable environment that on Earth is where life first appears in the fossil record. Not where life survived, where it started. That is a different Mars than the one most people imagine when they think about a cold, dead planet with traces of ancient water in its rocks. That is a Mars that had a chance. The argument cannot be resolved from the data the mission collected. The instruments were not designed to answer this specific question because no one knew the question was going to be asked. What would resolve it is a more detailed analysis of the site. Core samples from different depths. Measurements that require instruments that were not on the rover that found it. In other words, going back. No one has gone back. The scientists who would most want to go back to this site are not the ones who decide where the next mission goes. That decision involves engineering, budget, political priority, competitive science goals, and the calculations of program managers who have to weigh one unanswered question against dozens of other unanswered questions and choose which one gets the next decade of funding and attention. The Silica site is not winning that argument right now. The next missions to Mars are focused on other regions, other questions, other targets selected through the same careful process that did not select this one. The Silica site sits where it has always sat, on a planet that takes 7 months to reach, in a region that no current mission is headed toward. The question is still open. The site is still there, and the machine that found it, the one that lasted 55 times longer than planned, that was kept alive by dust devils no one predicted, that got stuck in a crust that looked exactly like every other crust, is still there too, right where it stopped, right where the wheel broke through. There is a version of this story where the machine completes its 90-day mission and goes silent exactly as planned. In that version, the crust holds. The wheels keep rolling. The machine drives past that patch of ground without incident, reaches the next target on the pre-planned route, collects the specified data, and eventually runs out of power in an unremarkable location with nothing unusual in the final telemetry. In that version, the Silica is never found. The argument about what it means, about whether Mars had the conditions for something beyond chemistry, is never started. Because the question is never asked. Because the wheel that would have asked it passed over the surface without breaking through. The 90-day mission succeeds. The question stays buried, 2 inches below the surface, on a planet 140 million miles away, in a spot that nobody selected and nobody planned for and nobody would have found if a wheel had not broken through a crust that looked exactly like every other crust. On a day that, by the original plan, should never have existed. The machine had been dead for 3 years when it made the most important discovery of its life. The calculation was wrong about when it would die. It was also wrong about what dying meant, because the machine did not go silent and take the question with it. The question is still here. The data is still here. The site is still there. And the argument, the one that started when a spectrometer analyzed material from 2 inches below the Martian surface on a day that should not have existed, is still going, quietly, in papers that cite other papers, in conference rooms where people who have never been to Mars argue about what happened there billions of years ago. The rover went silent. The discovery did not. Unvisited, unanswered, waiting for someone to decide that the question it accidentally asked is worth going back to answer, right where the map ran out and the discovery began. Thanks for watching, and I'll see you in the next one.